Hello everyone. So in this video, we are going to discuss about the experiment number 3 for your organic chemistry. So we're going to talk about hydrolysis of esters or the amide that we can perform. So let us understand first why this hydrolysis is so important to study. So if you talk about these molecules, let's say there are three molecules here. So these are the smaller part of any, like you can say these are the small molecules. We call them as monomers. Now these monomers, they can go on attaching to each other or they react with each other with the loss of water molecule. Okay. So to form a large molecule, this we call it as polymer. Now, this particular polymer is formed by the loss of water molecule. So we can call this reaction as condensation, or we can, since it is a specifically water molecule is lost in this reaction, we are calling it as the dehydration reaction. But what will happen if I add the water molecule to this large molecule? We have seen the small molecules like monomers, they are reacting with each other with the loss of water molecule. We call this reaction as condensation or dehydration process. Now, if the opposite reaction happens, like if the water molecule is added to this large molecule, what happens? They will again break down into the smaller part. That is, we will get our monomer part back. So this is a reaction where a large molecule that was your polymer, it has broken down because of water. So this process, we call it as hydrolysis. So in short, what is hydrolysis? It is a chemical breakdown of the substances with the help of the water. Okay. So what we have seen, there was a large polymer. Polymer, how it is generally formed? Small monomer molecules, they react with each other with the loss of water molecule. We call it as dehydration process. And if the water molecule is allowed to react with the polymer, it will break down into the monomer part again, that we call it as hydrolysis process. Now, how this hydrolysis is connected with our daily life? So if you talk about whatever the proteins that we eat, so if you look at this a protein part here, you can see this is the these are the peptide linkages of the protein part. So whatever protein that we eat, they are hydrolyzed in our body. So hydrolysis will take place, this peptide linkage will break, and we will get the respective amino acids back. Now these amino acids are stored in our body, and then we synthesize our own proteins as per the sequence decided by the RNA, right? So in short, the hydrolysis of protein in our body, it is the hydrolysis process only. That you can say the metabolism of the protein is the hydrolysis process. Not only proteins, the carbohydrates. You can see we eat starchy material or the carbohydrates that we eat. They are again broken down. It involves the hydrolysis step only, and we get the formation of glucose. Now this glucose is broken down into glycogen and it is stored in the body so as to have the energy source. So breaking down the large carbohydrates into the smaller carbohydrate part, that is also kind of like a hydrolysis. Then the fats or the oils part, we call them as a triglycerides, right? So we can hydrolyze them so that what will happen, they will break down into two parts. One is this part, that is your glycerol part, and the remaining I will get the formation of fatty acids. This is very important. Generally, if you do the alkaline hydrolysis of this, rather than getting fatty acids, you get formation of the salt of fatty acids, and we call them as soap. So we also call this reaction as saponification reaction. That's why the hydrolysis of ester is very important to us, because we are dealing with this reaction in our daily life. So now in today's experiment, what we are going to talk, we are going to talk about the hydrolysis of ester. So ester, functional group, RC double bond O OR dash. It is hydrolysis. Definitely it is the reaction of water. Today we are going to talk this hydrolysis reactions are generally very slow processes. So you can catalyze them with the help of acids or with the help of base. In today's experiment, we are going to talk about the alkaline hydrolysis of ester. So you can see in step number 1, we have added NaOH. That means all this hydrolysis we are going to carry out in presence of base, that is alkali. This is our step number 2, how to recover the product. I will come back to this HCl part later on. So there are two steps. First is alkaline hydrolysis of ester, and this is a second part. Once the product is obtained, we can just recover the product with the help of the acidification reaction. So as to get our two products, one is the carboxylic acid and second product is the alcohol. We can carry out this reaction even with the help of amide. So you can see here amide. Amide can be hydrolyzed with the help of same condition, so as to get the carboxylic acid. Only the difference is, previously in the case of ester part, we are having alkoxy group here. In amide, we have this NH2 amino group here. So alkoxy part is giving us the formation of alcohol. So amine part, that is amino group, is going to give us the formation of ammonia as a byproduct. Okay, so this is the hydrolysis of ester or the amide reaction. Now let us discuss about the mechanism. So first we are going to talk about the hydrolysis of ester. I have written some background reactions over here so as to make it convenient for us. Okay, first of all, the alcohol, sorry, the ester part which we have. You can see this particular carbonyl oxygen which has the lone pair of electrons. Even this alkoxy group, that oxygen has the lone pair of electron. Now we are carrying out this reaction in presence of base, and base is going to provide us the OH minus. OH minus, if we have the, since we have used the NaOH, that OH minus, it is going to act like a nucleophile. So this is your nucleophilic hydroxyl group. And in the compound ester, you can see this carbon. We say carbon and oxygen. This is electronegative oxygen. So carbon is having electrophilic character. So there is a nucleophilic attack of this nucleophile to this carbonyl oxygen, sorry, carbonyl carbon. So once they will form this bond, what will happen? These electrons, I will just highlight them, let's say with a different color. These electrons which are present in this bond, they will be given to the oxygen back. So here the new bond is formed between this OH and the carbon, and these electrons are returned to the previous oxygen. So what will happen now? This oxygen will have this lone pair of electron which is given from the carbon, and rest of the electrons are as it is. So these two electrons are as it is, which were already present, but it is getting one lone pair from this carbon. So it is acquiring this negative charge. At the same time, we have also set this nucleophile, this OH minus, it's sharing its electron. So here the new bond is formed between this carbon and this oxygen with the help of that these two electrons. Okay, but now this carbon will try to get this electrons back so as it can form that double bond again, because in resonance stabilization the double bond is more stable compared to the single bond. So what will happen in this reaction? Again, this lone pair of electron will come here back and it will try to form the carbonyl group again. Once this is formed, now out of these remaining three groups, you can see there is alkyl group, there is hydroxy group, and there is alkoxy group. In these three groups, this alkoxy group is a better living group. So once the oxygen will form a new bond again with the carbon, this alkoxy group is going to leave. Okay, so now this oxygen already have the lone pair of electrons. Now this is coming back, so this bond is formed here again. Two lone pairs are as it is, but alkoxy group is living. So alkoxy group, oxygen, we're having the two lone pair. Now it's one more lone pair, it's coming here. Now this alkoxy group, if you'll see, this is a better, you can say it is a strong base, because it can abstract the proton very easily. And now if you look at this product, this is your carboxylic acid. So in short, now in the reaction, there is a formation of one acid and the strong base. So now what will happen? Of course, they are going to react. This strong base, the alkoxy group, which is left from here, it is a strong base and it is going to abstract the proton. So how will it abstract the proton? You can see here, there is a proton. So proton will give up its electron to the oxygen, and then it will leave. So that you can see this alkoxy group, it will share this electron with this hydrogen. So now you can see here oxygen, its two lone pairs are as it is. One is utilized in formation of bond with the hydrogen. Okay. Whereas if you look at this oxygen here, this oxygen was having the two lone pair previously. Now one more lone pair is coming because the bond is broken with the proton. So in short, we end up with the formation of carboxylate anion. Okay. Now, if you remember this OH minus, from where it is coming? It is coming from the base. That is the base which we have used is NaOH. Now, NaOH may say this OH we have utilized as a nucleophile. The reaction is done. So remaining this sodium part, it is going to form the salt part over here. So instead of getting carboxylic acid in the reaction, I'm getting formation of the carboxylic acid salt. So sodium or whichever base you are using, accordingly you're going to get the salt. But I want finally the product that is carboxylic acid. I'm getting formation of salt here, if we can see. So therefore, in the second step of the reaction, if you remember what we have done here, there is a first step with the reaction with NaOH, and then second step was acidification. So after reaction with NaOH, what is our end product? Our end product is formation of this carboxylate salt. Now this carboxylate salt we are going to acidify with the help of HCl. So of course this sodium has affinity for the chlorine, so it will form the byproduct NaCl, and we will get the formation of the carboxylic acid. Okay, so this is your mechanism where there is a nucleophilic attack of the OH minus, that is hydroxyl ion, on the electrophilic carbon, so as to give the addition product. Electrophilic addition will take place, and this particular lone pair will come back to form this double bond again, and the alkoxy group will leave. This alkoxy group, which is left from the molecule, it is a strong base. It will abstract the proton from this molecule to form the carboxylate ion. This carboxylate ion with the sodium forms that salt, and that salt can be acidified in order to get the carboxylic acid. So in short, what is your experiment? Whatever ester is given to you, we are going to carry out its hydrolysis in presence of water and base, that is NaOH we are going to use. And once we will get the formation of the salt, we are going to acidify that salt to recover the carboxylic acid. Okay. We can do this reaction even with the amide, right? We have discussed just now. The mechanism is exactly the similar one. Again, you can see here hydroxyl group is there. This has the negative charge, so it has three lone pair. It is going to attack on this carbon, which is electrophile. Your hydroxyl group is the nucleophile, so there is a nucleophilic addition. Now, when this will happen, the lone pair of electron will be returned to the oxygen. Oxygen already have the lone pair, two lone pair here. So it is getting one more electron pair here, as a result of which it will acquire this formal charge, negative formal charge. But now this electron pair will try to come back to the carbon to form the double bond. And from this, now you can see there is NH2 group. It is going to become a good living group. So it is going to leave from the molecule. So carbonyl, you can see here double bond is formed, and I'm going to get this, the nitrogen, which was previously having one lone pair. Now when this bond is broken, another lone pair is coming. So I'm getting the formation of the amide anion. This amide anion, again, it is a strong base. If you remember previous case, in the case of ester hydrolysis, there was alkoxy group, but now we have this amide leaving group. This amide group is a very strong base, and you can see here our product, it is carboxylic acid. So of course there is acid base reaction, and equilibrium will shift to the right side. This will abstract the proton. So proton is left from the molecule. It will share this lone pair with the hydrogen. Hydrogen will give up its electron to the oxygen and it will leave. So in short, I'm going to get the formation of carboxylate anion. Again, we are carrying out this reaction in presence of the NaOH. So definitely it will form this sodium salt. And the sodium salt, we can then finally acidify in order to recover the carboxylic acid. Okay. So this was the mechanism part. Again, this is nucleophilic addition. So as to give this adduct will form that double bond again to leave, to make this NH2 group or alkoxy group as a living group. They are a strong base, attacks the carboxylic acid again to form the carboxylate ion, and carboxylate ion salt that is acidified with the HCl so as to give the formation of carboxylic acid. Okay, so this was the overall reaction, hydrolysis of ester or hydrolysis of amide. Now, specifically, which ester we are going to take it for the experiment? So today's experiment, we are going to start with ethyl benzoate. Okay, in the nomenclature part, if you remember, I'm just revising this part, R C double bond O O R dash. So nomenclature, IUPAC nomenclature, we call this compound as alkyl alkanoate. So alkyl is the one which is attached to the oxygen. So you can see here ethyl group is attached to this oxygen, alkoxy group, and the remaining part is the benzene, benzoic acid part. So we are calling it as benzoate. Its hydrolysis, again, there are two steps. First is alkaline hydrolysis and the second one is acidification. So when this reaction will happen, it is expected, see, alkoxy group is going to leave. So this part is going to give me formation of benzoic acid and the byproduct will be ethanol. So our aim is to prepare this benzoic acid by the hydrolysis of ethyl benzoate. Okay, so let us start with the actual experiment now. This is your reaction. Ethyl benzoate on hydrolysis going to give me benzoic acid. So what is the different apparatus we need for the reaction? So apparatus needed, you need a conical flask. We are going to perform the experiment in the conical flask. Measuring cylinder to measure the amount of the different reagents that we are going to use in the reaction. Glass rod you need, dropper you need, test tube, funnel for the filtration, watch glass for the collecting sample, beaker, stand, wire gauze, that everything is there in your lab that is needed. Okay, what are the chemicals required for this experiment? So chemicals required are, we need first of all ethyl benzoate, that is our ester part, right? We need 10% of aqueous NaOH. We are going to use the aqueous 10% solution for the reaction because this is alkaline hydrolysis of ester. So we need alkali. So we're going to take the 10% of aqueous NaOH solution. So this aqueous solution will be already prepared and it will be given to you. Okay. Then you need concentrated HCl and water for this reaction. So these are the chemicals which we need. So let us begin with the reaction. First of all, in the lab, we are going to carry out this reaction in the conical flask. So any 100 ml conical flask you will take. The ethyl benzoate that we are going to use in the reaction, that will be given to you in the burette. So like that, we are going to keep, we will make the assembly like this. We will keep this ethyl benzoate in the burette so that you can like exactly you can take 1 ml of ethyl benzoate in your conical flask for the reaction. Now, during regular practicals, you are going to take that 1 ml of ethyl benzoate in your conical flask. In the exam time, it will be already given to you. The maybe 1 ml or some unknown amount will be given to you. Okay. So your first task is, this is the burette containing the ethyl benzoate. So with the help of like this conical flask, you will take it to the burette and you will take out 1 ml of the ethyl benzoate in the conical flask. Okay, so our first reactant is there in the conical flask. Now our second reactant, what was our second reactant? We are going to carry out this reaction in presence of alkalis. This is alkaline hydrolysis of ester. So 1 ml of ethyl benzoate we have taken, that is already there in the conical flask. And now we are going to take 10 ml of 10% aqueous NaOH. So you can take it with the help of the measuring cylinder, or you can take approximately one test tube of 10% aqueous NaOH. Okay. Now you will pour it in the conical flask, that 10 ml of 10% aqueous solution, and mix this solution. You will find as you'll mix the solution, there will be some kind of white solid generation will take place. To some amount, the salt formation take place during this addition only. And therefore, you can see the some white solid will be formed in the reaction. Okay. Once this is done, so till now what we have done, we have taken 1 ml of ethyl benzoate in the conical flask, and in that we have added 10 ml of 10% aqueous NaOH. So we are getting a little bit solid formation in the reaction. Now we are going to add 3 to 4 ml of water in that. So you can take the test tube and approximately 3 to 4 ml of water you will add it to the solution. The solid which is formed in the reaction, it may not dissolve in that water. So don't worry about it. When we'll continue the heating part, that time the complete solid will dissolve. Okay. So now we have added 3 to 4 ml of water to the solution. Now next part, we are going to do the heating part of this reaction. So heating part के लिए क्या क्या चाहिए? We need a burner. On that you will put the wire, this stand, and then on that you will keep the wire gauze. And the conical flask now, which is containing 1 ml of ethyl benzoate, 10 ml of 10% NaOH, and we have added 3 to 4 ml of water. So this is your conical flask, and you're going to continue the heating. So now you can see, as you'll continue heating slowly, that white solid will start it will start dissolving, and you will get a clear solution like this. Okay, so slowly that white solid which is there, it is going to get dissolved. You will continue this heating for around 15 to 20 minutes. Okay, so solution is going to get boiled. The white solid which was formed, it will get dissolved. If suppose in case the white solid is not dissolving, what you can do it, you can add some extra water to the solution. Not much water, don't add extra water to the solution. It is expected कि जितना volume हमने लिया है अभी तक, उसमें वो solid dissolve होना चाहिए. Okay, so continue heating for 15 minutes, 15 to 20 minutes. You will find that solid which was formed, the salt which was formed, it will get dissolved in water. Okay, so till now our experiment is complete. That is, our step number 1 is complete. We have done the alkaline hydrolysis of ester. And what is expected at the end of alkaline hydrolysis of ester? What is expected to get? I started with the ester, that was this, right? I started with this. So what is expected for me? I'm going to get the salt of this benzoic acid. Okay, and byproduct is what? Ethanol. But ethanol is water soluble, so that will get dissolved over here. And even this salt, that will also get dissolved in the water. So that's why we are getting here a clear solution. Okay, now let us proceed for the next step. Now this particular solution, after heating for 15 to 20 minutes, allow it to cool to the room temperature. Okay, now we are going to carry out our second step. What was the second step? In the mixture now, I have the salt of benzoic acid. I want benzoic acid, and to recover that salt, I need to acidify the solution. And for acidification, I'm going to use concentrated HCl. Okay, so what is expected? Put the drops of concentrated HCl, stir the solution. As you'll stir the solution slowly, that white solid of benzoic acid will start coming out. You can stir it with the help of glass rod, or you can simply mix the solution with the hand. You can take the conical flask in the hand and you can mix the solution. Okay, but ये जो step है, drop wise HCl, concentrated HCl को add करना है, ये slowly drop wise करोगे. Okay, so as you'll add the solution, mix the solution, and see that there is complete acidification. How will you see that there is complete acidification? Go on adding and check whether are you getting the more and more solid formation. Now you can see the solid formation is complete. Entire solid has come out. That means it is complete. If you add more concentrated HCl to that solution, observe whether it is giving more solid or not. Or you can check with the pH paper also. We are supposed to acidify the solution. तो तुम्हारा जो pH paper है, that should turn to red color. If it is red color, that means the solution is acidic in nature. No need to add more concentrated HCl. Or otherwise also, if you add the solid, let's go concentrated HCl to the solution, you can see on the surface whether there is more solid formation or not. If you observe more solid formation, go on adding more concentrated HCl. So once the acidification is complete, we now have that solid of benzoic acid. Okay, so now in the conical flask, right now in the conical flask, I have a benzoic acid in the solid form. Okay, so till now what we have done, we have taken in the conical flask 1 ml of ethyl benzoate. In that we have added 10% of 10 ml of 10% of aqueous NaOH. Then we have added 3 to 4 ml of water. We have boiled the solution so as to get a complete hydrolysis, and in that solution we have added concentrated HCl to get the benzoic acid. Okay, now what is the next part? We are supposed to filter this solid. So filtration assembly. So what you are going to do, stand, उसके ऊपर हम funnel रखेंगे, filter paper रहेगा, filter paper का cone बना के that we will keep it in the funnel, and this you can keep the beaker below so as to recover that solvent. Now this conical flask, you will pour it on that funnel. So when you'll pour it, what we'll get, we will get the formation that is solid of benzoic acid solid, which will be recovered in the funnel, and the remaining water you will get it here. Okay, so now I have my product benzoic acid in the funnel. I'm supposed to dry this product, so transfer it to the watch glass. But before you transfer it to the watch glass for the drying purpose, I'm going to advise you, this watch glass, you clean it first, you make it dry, and make note down the weight of this empty watch glass, so that later on calculating the practical yield will be convenient for you. Okay, so I'm going to do what I'm going to do. I'm going to take this watch glass, I'm going to dry it, and I'm going to take the note down the weight of the empty watch glass. Right now, you just note down this weight of the empty watch glass, that is 1.304 gram. Okay, so you can make a note of this in your notebook. So weight of the dry and the clean watch glass is 1.304. Okay, now what you will do, transfer this solid benzoic acid to this watch glass. Now we're going to do the drying of the this benzoic acid. Benzoic acid is having comparatively higher melting point, and therefore we can do this drying part on the water bath. So water bath कैसे arrange करोगे? Again, burner पे stand रखना है. Then on that we will keep the wire gauze. Beaker लेना है, beaker में पानी लेना है. You can put some porcelain piece in that so as to avoid the bumping of water outside. And on the top of beaker, you can take 100 ml beaker, and on the top of that 100 ml beaker, you can keep this watch glass. Okay, and continue this process till you get the dry product. Now with the help of the spatula, you can break down those lumps which are formed, so that the drying process will be faster. So make sure this process, in this process you will completely dry the product. Okay, once this is done, the next part is weighing part. Now I know the weight of the empty watch glass, right? So I can directly keep this clean dry watch glass. Now what, this watch glass is already having your product. Okay, once you remove it from the beaker, you can wipe it out from the bottom with the help of filter paper and make it dry. Okay, so now the next part is weighing part. So balance pay, first how we observe, balance पे tear button दबाना है, so it should show you the zero reading, and then put your watch glass on that. Now note down this reading. This is 2.047 gram. Okay, but now I can see this is my watch glass plus the product. Together it's showing me the reading of 2.047. Okay, so what I can say, the empty watch glass, we have noted the mass of that, how much it was. It was 1.304 gram. And now I have this watch glass along with my compound, it is weighing 2.047. You can calculate this difference. I'm not going to give you the reading right now. You can calculate the difference and you will note it down as the practical yield. So this is your practical yield, that is the amount of solid which you are getting in the reaction. Okay, so this is experiment is complete, esterification is done, acidification is done, solid is recovered, solid is dried, and it is weighed. So we have completed the practical yield part, but we need to calculate the percentage yield, and to calculate the percentage yield we have to calculate the theoretical yield. So let us see the reaction part again. What was the reaction? The ethyl benzoate on hydrolysis is giving me the formation of benzoic acid. So now we will use the mass relationship between this ethyl benzoate and benzoic acid. Now in this balance reaction, we can see they are in 1:1 ratio. Okay. So while doing the calculation, we have already performed two experiments before this. So you know how to calculate the molecular formula and the molecular weight of respective compounds. Okay. I'm expecting you will calculate this. Okay. I'm going to give you only the tentative idea how you're going to do the calculation, but calculation part I'm expecting you will do it because we have already discussed this in two experiments before. You can see here first point which is asked is molecular formula and molecular weight of ethyl benzoate. So now you can see in ethyl benzoate there are 6 carbon in this benzene ring, seventh one this is carbonyl carbon, and 2 are in the ethyl group. So total carbon if you see there are C9, and hydrogen 5 in the benzene ring and 5 in this ethyl group. So there are 10 hydrogen and there are 2 oxygen. Okay. I hope everyone knows how to calculate the molecular weight. So I'm expecting you will calculate this molecular weight. I'm writing this as A. Okay. Similarly, you will calculate the molecular formula and molecular weight of benzoic acid. The way I have told you how to calculate the molecular formula, you can calculate for the benzoic acid. And then from that, you will determine its molecular weight. I'm writing it as B now. Now, what is the mass relationship between ethyl benzoate and benzoic acid? They are in 1:1 ratio, right? So I'm expecting A. A means what? The molecular weight of ethyl benzoate on hydrolysis is going to give me B, that is molecular weight of benzoic acid. This is a mass relationship between the two compounds. Okay, but we started with 1 ml of the ethyl benzoate. So I need to convert this into gram. So for that, I need the density of ethyl benzoate. Density of ethyl benzoate is 1.05. So I'm writing it here. It is 1.05 gram per ml. Okay. So if it is 1 ml and density is 1.05, of course, the mass will be 1.05. So you have taken 1 ml of ethyl benzoate in the reaction, which is actually you have taken 1.05 gram of the ethyl benzoate. Okay. So now we are expected to do the cross multiplication. So 1.05 multiplied by this is B. B is the benzoic acid molecular weight, which you will get after calculation, divided by A. That is the molecular weight of ethyl benzoate. After doing this calculation, you will get the theoretical yield. Okay. So now in the previous slide, you have the practical yield that you will get it after subtraction of this empty watch glass weight from this amount. Okay. So after this, you will get the practical yield. Here you will calculate the theoretical yield. And finally, you will do the percentage yield calculation. So what is percentage yield का formula क्या है? Practical yield जो है divided by theoretical yield multiplied by 100. Okay, I hope till now it will be easy for you to calculate. Just calculate it. Whatever doubts you have, we will discuss it definitely. Okay, but try to calculate this yield. So once the calculation is over, our next part is the purification. We have got the benzoic acid, right? So we need to do the purification of benzoic acid. Now for the purification, what we use the process that is crystallization. Now, in the crystallization, we are supposed to do the selection of a solvent. How should be the solvent? It should be inert, should not react with the benzoic acid, right? It should be less viscous. And in that solvent, my compound should be soluble only on heating, not at room temperature. That is important condition. My compound should be insoluble in the solvent at room temperature, but at high temperature, that is on heating, it should become soluble. This is the criteria for the selection of solvent. तो हमारे लैब में अगर तुम देखोगे तो अलग अलग solvents available है. Simply हम पहले start करते हैं water से. We check the solubility in water. Selection of a solvent for any crystallization process is completely a trial, you can say trial error method. So you have to try different solvents and you need to check. So whatever the compound you have, with the help of small amount of compound, you can see the solubility of the compound in that solvent, and then you can decide a perfect solvent for the crystallization. Now for today's experiment, we are going to use water as a solvent. Okay, because in water, benzoic acid is insoluble at room temperature, but it is soluble on heating. So best solvent for the recrystallization of benzoic acid is water. Okay, so what we are going to do, we are going to take the compound benzoic acid in the test tube. We will do the purification in the smaller amount only, so you can do this recrystallization in the test tube itself. Okay, so take small amount of benzoic acid in the test tube, and as I told you, we are going to use water. Use minimum amount of water. Okay, I've written here 3 to 4 ml, but if suppose your compound is becoming soluble on heating, even in 2 ml of water, that is also enough. So try to use minimum amount of water. So add water to your test tube. Okay, so now we have a mixture. You can see here there is a solid benzoic acid and there is water. We can see the benzoic acid is not dissolved in water. That is a condition for the selection of solvent. My compound should be insoluble in the water at room temperature. So now with the help of test tube holder, we can directly heat the solution. Okay, now previously जो experiments हमने किए, उस experiments में क्या था, we have used ethanol as a solvent, right? 50% ethanol or 100% ethanol as a solvent for the recrystallization. Ethanol is a flammable liquid, so therefore it is expected we are not supposed to heat that test tube directly on the flame like this. Okay, what we have done, we have used the water bath. In water bath we have kept the test tube. Now in this case we are using water as a solvent, right? And therefore I'm going to do direct heating of this test tube on the वायर गॉज, सॉरी डायरेक्टली ऑन द बर्नर. ओके, सो टेस्ट ट्यूब होल्डर से उसको पकड़ना है और डायरेक्टली हीट करना शुरू करना है. नाउ यू कैन सी देयर द सॉलिड व्हिच वाज देयर, नाउ इट इज completely dissolved. Okay, so completely dissolve that solid, it is indicating now compound is soluble on heating. So what is the next part? We are going to do the filtration. So take this test tube in the hot condition only. We are going to do the filtration of this. So for that you need a funnel. Keep it on the stand and put a small piece of cotton in the funnel. Okay. In hot condition, we are going to filter this solution through the funnel. What is the purpose? What is the reason that we are going to do the filtration through this funnel through the cotton? Because there are two types of impurities. One is water soluble impurities, one is water insoluble impurities. Okay, so whatever the water insoluble impurities are there, that will get accumulated on this cotton. So the impurities which are insoluble in water, that will get filtered. So now in the water we have our pure compound. Impurities are removed here. Okay, so now next part, allow this particular test tube to cool to the room temperature. जैसे तुम room temperature पे cool करोगे, you can see the crystals of the benzoic acids are coming out. Okay, this is expected. Okay, तो इसको allow करो to room temperature to cool it to the room temperature. So what is the next part? We are going to filter these crystals. तो ये जो funnel है, अब इसमें cotton के जगह पे लगा दो filter paper. And finally filter this solution through that filter paper, so that on the filter paper I will get the pure crystals of benzoic acid. Okay, so till now what we have done, we have used water as a solvent for the crystallization of benzoic acid. First heat it, filter it through the cotton to remove the water insoluble impurities. Allow it to cool to the room temperature. Slowly the crystals will grow and these crystals we can filter. अब जो filter paper पे मुझे मिलेगा, that is my pure benzoic acid. Whether the purification is done perfectly or not, that we can determine with the help of melting point. Okay, so how you take the melting point, I've just taken a picture here because I guess FY and in the previous experiment also we have discussed this many times. Okay, so generally we get this capillary in the lab which is open at both the end. So what we do, we just heat at one end so as to make it seal. You can see this is a sealed capillary tube. In this we are going to fill the compound. How much compound you generally take in the capillary tube? This is a thermometer having certain mercury over here. So height of mercury and your height of the compound should match. Approximately 3 to 4 mm height. That much solid you will take it in the capillary. If you find the benzoic crystals are very large and they we cannot put them in the capillary. You can crush those benzoic acid crystals, make a fine powder, and then you can put it in the capillary tube. Now tie this capillary tube with the thermometer and then put it in the Thiel's tube. Okay. And then in the Thiel's tube arrangement, everyone knows that we heat it at this bend part, so that what happens as you're heating the solution at the in the hot condition, that becomes lighter, so that goes up, and the cold solution comes down. So in this way, this Thiel's tube has the uniform distribution of the heat capacity, and that's why rather than using simple beaker, we go for use of this Thiel's tube. Okay, everyone knows how to take the melting point, the point at which that solid will turn to the transparent liquid as it forms. As you are taking the melting point, you will find first a small amount of solid will first become a liquid. As it becomes a liquid, stop heating, let it continue heating, because you have already provided some amount of heat here. Okay, so as you see, a very small amount has started becoming liquid. Stop heating, because you have already provided some heat. By the time it reaches to that test tube, it is going to melt completely. So now you completely observe that compound. The moment at which the entire solid becomes liquid, you will note it down as the melting point of your solid. Okay, I'm not going to give you the exact melting point, as we cannot determine it by the practical experiment. I want you to search it. Okay, so search the melting point of the benzoic acid online and write down that melting point in your experiment. Okay, so this is, so we have completed the experiment. So we have completed the hydrolysis of ester, that is ethyl benzoate, has been converted into benzoic acid. We have recovered the product, and then purification of the product has been done. Calculation karna hai, practical yield and theoretical yield ka calculation I have explained you. So write down that calculation in your notebook. So now next part, how you're going to present, or how you're going to give that experiment writing. Everyone knows all these instructions. You are writing the experiment in your notebook or A4 size papers, whatever you are taken. This time you will write that experiment in the same format: the title, reaction, the requirements, the procedure, mechanism, observation, calculation, and finally the purification part also, which solvent you have used, what is a melting point, everything you will note it down. Okay, scan the pages, save it in the PDF form. Again, I'm repeating, still some students are sending with the different codes. It's very difficult for us to manage those files. So I want you to name this file in this way only. This is our third experiment of organic. So XXX, this first three digits are nothing but your last three digits of your seat number. That is in short your roll number, followed by O and 3. This is your third experiment, so it should be written O3. This should be your file name, that PDF name. Okay, now today is 4th of November. We are expecting you will watch the video till 5th of November. You will write it down, the experiment. You will complete it. We are going to upload the link for the submission of PDF file and the Viva questions on 6th of November. Okay, so keep your PDF file and the Viva, that is prepare for your Viva by 5th of November, so that you can upload your file on 6th of November. Okay, that's it for today. Thank you.